Okay, thank you, everyone, and thank you to the organizers, especially for putting all of this together. My name is Troy Raen. I will be leading the tutorial for the Pitt Google Broker today. We are currently running the ZTF streams nightly. We're about 90% of the way to running DCAM streams, so those should be available soon. This tutorial goes through how to access ZTF data. Our broker is 100% Google Cloud based. All of our data, all of the data is public, and you can access it using Google's various software development kits for the command line, Python, Java, and other languages. I have written a little Python package, PGB utils, that is a collection of helper functions for using the Google Cloud SDK and some other things to start working with the data. You should think of this Python package as a set of examples about how to use these underlying tools to kind of give you some entry points here. This code samples notebook is a condensed version of the full tutorial, so you can refer to the full tutorial for sections that you're interested in. Today, I'm going to cover sections 3 and 5 on querying the database and connecting those queries to Apache Beam pipelines in section 5. And here with the pipelines, I will give you some working examples with templates where you can insert your own filters or whatever processing you want to do, maybe fitting or classifying light curves, and run a full data pipeline with that. I'll leave section 4 for you to look at later if you're interested. We are also publishing nightly message streams through PubSub. You can actually listen to those now, but that's not in this tutorial. If you're interested, please contact me. I can send you working examples. I can also show you how to plug these Apache Beam pipelines into PubSub streams. So let's skip down to just a little bit of setup here. In order to make API calls to Google Cloud resources, you need to create a project on the Google Cloud platform. It's very simple. You just name your project and then copy the project ID. You'll put the project ID here down in this second cell. Then you can run through the rest of this setup here. Let's skip down and query the database. So we will start in Python. These database queries just use standard SQL. Here, you can get a little bit of information about the tables that are available and what their schemas are. Let me pop open the table of contents here and just show you, if you want to access the Google Cloud SDK directly and write your own SQL queries, just skip down here to this direct access section. These other sections here go through some of the PGB utils tools to make some common things like light curve queries, so that not everyone has to write the same SQL queries for those. So that is what I'll go through today. We'll look at querying some light curves. First, we just choose some options. Which columns do you want returned? You can optionally choose some specific object IDs. You can limit to only a sample of what's in the tables. Then you call query objects. This is a wrapper for the Google Cloud API that generates the SQL statement for you and returns a data frame by default. In this first call, we do a dry run to tell us what's going to happen. We'll skip that dry run in future cells here in this notebook. And here's our data frame results. They are indexed by object ID and candidate ID, and they have the columns that we asked for. If your query returns a lot of data, you might want to use a generator to step through data frames of individual objects so you don't have to load everything into memory at once. Query objects can return one for you, and this will show you how to do that. That function can also return JSON formatted strings or the raw query job object from the Google Cloud API. Here in this next section, you can just plot a light curve here once you've got a data frame. I also wrote a little something to just demonstrate a cone search, so you can look at that if you're interested. If you want to use the command line directly, here in this section, I've demonstrated how to do that. Here's a bunch of help stuff. Here's how you can look at the table schemas and what's available, and then actually running some queries. Okay, in this last section, I will demonstrate how to use these database queries to feed light curve data into an Apache Beam pipeline, apply some user-defined filters and processing functions, and write out the results to a text file. So first, I'll give you a preview of the pipeline that we will create. Beam overloads some Python operators. So the pipe character means apply. This double greater than symbol just allows us to name the step. And so I'll go through this in more detail, but here we are just chaining our pipeline steps together. So the output from one pipeline step gets piped directly into the input of the next step. Okay, let's look at the same code with some comments here. The 0th thing we do is just to instantiate the Beam pipeline object. And then we start the pipeline just by piping it into this read function. So this will read data from BigQuery. The arguments in here will be the same kind of query arguments we used to get light curves in the last section. It's convenient to work in pandas data frames. So you can call this a very simple function that we wrote to just typecast the query results into a data frame. Then you have light curve data frames in your pipeline, and we can do some processing with it. And so these middle steps here are actually applying some user-defined functions. We'll do a filter and some processing, and I'll go through those in a little bit more detail. The last thing that we do is just to write the results out to a file. You can use this pipeline as a template and configure the database query to get the data that you want, and then insert your own filter and arbitrary processing. But this is a working example. Sorry, I'm skipping around here. Let's see right there. We covered most of what you need for the database query in the previous section. So let's just look at the functions for the filter and the processing that you can play around with here. Both of these functions will take as input the data frame containing the light curve history of a single object. Here in the filter, you can calculate whatever you like using that data frame. And the filter should return a Boolean, where true means we keep the data frame, false means we drop it.
2 minutes.
Thank you. This other function is a function wherein we can just do arbitrary processing. And so here we just calculate the mean magnitudes per passband, but you can insert whatever you want here. You can do light curve fitting, classification, things like that. We will write this out to a file. And so here in this last part, I'm just formatting it into a comma separated string so that it writes nicely. Okay, this next cell is the read and write configs. And we went through those earlier with the Beam queries. And that's all we need to run this pipeline. So now this will run all the way through. It'll grab the data from the database, do the processing, and write out the results. Here we can look at the first results here. This job is configured to run locally here in Colab, actually. But when you're ready to run large-scale pipelines, it's straightforward to deploy this pipeline or similar ones to run in the Google Cloud or in other places like Amazon Web Services. And we can plug these same pipelines into PubSub streams rather than the database and run on the live streams as well. The full tutorial has more information about this and many other things. And with that, I'll leave it. Thank you.
Thank you, Troy. So if you have any doubts, we have time for a very quick one, or let it in the Slack, in the channel. I don't see anyone.
There is one in the chat.
Yeah, it says, is Beam like Dask or Spark?
Oh, I'm not super familiar with either of those, but I believe that Apache Spark is a runner for Beam pipelines. So Apache Spark lets you run these Beam pipelines in the, I think in the Amazon cloud or something like that. Yes, they're related. The full tutorial has some links where you can find some more information about that.
Okay, thank you. Let's move on now.